Hey everybody, welcome to today's K3s online training, the first of its kind, the first we've done of these. Really happy to have you all on this inaugural training. If it goes well, we'll hopefully have this again once a month, we think. I want to let everybody know while we're just at the very beginning that this session is being recorded. We have about 90 minutes scheduled, but if you need to jump off, you can't stay the whole time for whatever reason, you will receive a recording and the slides, whatever files you need for the demo after the training. So with that out of the way, let's dive in as a way of introduction. My name is Matthew Shear. I'm a marketing manager here at Rancher. I put my email there, matthew@rancher.com. If you need to get any resources or have any follow-up questions, please don't hesitate to reach out. And our presenter on the line, who's really going to be doing the heavy lifting, and I know has been doing a lot of prep, very grateful for Mark, is Mark Abrams. Mark, are you there?
Hi, yes, I'm here.
All
Hi,
right.
everyone. Mark Abrams, field engineer with Rancher Labs.
All right, good to have you, Mark. And so we'll be hearing more from Mark. The training. I just want to give everybody a couple more housekeeping notes so that we're all on the same page. So, the presentation probably be about an hour. Just depends how long it takes. So please bear with us. This is a live demo. And ask your questions early and often. We try to make this as responsive as possible, do our best to not leave before every question is answered. GoToWebinar has a handy chat feature, so just click on that questions tab, ask your questions. If for whatever reason you want it to be private, just let us know. Otherwise, we usually answer them out loud for the benefit of everybody on the line. This session, as I mentioned, is being recorded. If you go to our YouTube channel, the URL is right there. You will find, after the session, you'll find this training as well as many, many others you can peruse at your leisure. We also have a ton of continued resources and a huge community dedicated to all these different open source technologies, especially K3s. So if you go to slack.rancher.io, totally free to join our Slack community, thousands of members. There's hundreds of members on the K3s channel, so just pound K3s. And then the forums.rancher.com for more in-depth discussion and product announcement, release announcements, and notes and things like that. We also have a lot of upcoming classes. This coming Friday, we have an online meetup. Our director of community, Jason Van Brackle, will be presenting on the new service mesh and Istio features in Rancher 2.3 preview. And then the coming week, Sheng Yang, the principal engineer for Project Longhorn, will be presenting about Project Longhorn and persistent storage. Project Longhorn slated to go beta later this year. So it should be really, really interesting. Storage can be a pretty complex subject, and Sheng is one of the best in the world on it. So don't miss out on that. So with that out of the way, I'm going to pass this presentation over to Mark. Make you the presenter, sir.
Okay.
All right, just passed it over
So
to you.
everybody should see the upcoming classes screen still.
Yes, that is what I see. You are good.
Great. Okay. So so our agenda for today, I'm going to do an overview of K3s, and then after the overview, I'll demonstrate K3s, and this is a lot of command line demos. So a lot of this will be in the command line. I'll talk a little bit. There'll be a few slides in between demos to try and give you some visuals on what we're talking about. And at some point, I think, Matthew, if there are questions, I'll stop and break for questions. If you feel like I need to answer something in the moment, please don't hesitate to interrupt me and let me know what the questions are.
Sounds good. Sure thing.
All right. So K3s is a lightweight certified Kubernetes distribution. It is built for production operations. So it's designed to be used in production. And it was validated as, what makes it certified is that it was validated by the CNCF, the Cloud Native Computing Foundation, as a true Kubernetes distribution. It's a binary of about 40 megabytes and uses about 250 megabytes of memory consumption. And I'll actually demonstrate a process in a little bit that will show that. The 40 megabyte binary is sort of not interesting in the sense that it's a compressed binary. So, when it's unpacked, it's a little bit larger, but it is small and it is easy to transport over the wire. And in addition, Kubernetes itself is multiple binaries. And so that's one of the things that really makes this unique, is that this is a single package that does all of the container orchestration that you get from Kubernetes. So it's a single process with integrated Kubernetes master, kubelet, containerd. And then for the database, we're using SQLite. We set up this to use SQLite instead of, or in addition to etcd. So you could use etcd if you wanted to. And actually the latest version of K3s allows you to specify whether you want to use PostgreSQL or MySQL. You can use different relational databases. And this is interesting for a number of use cases, especially in enterprises that already have relational databases in use and really understand that how to manage those. For all intents and purposes, managing etcd is more than half the battle of managing Kubernetes clusters. So when we released it, it was simultaneously released for x86 and ARM64 and ARM version 7. So you can run it on any of those architectures. It is an open source project. It is not a product. So while I am a employee of Rancher Labs, this is not a Rancher Labs product. We don't sell k3s. So you can just go to GitHub, download this, run it, try it out, and give us feedback. And I'll show you a whole bunch about how to use it today. So what did we do to create K3s? We removed a bunch of unnecessary code. And what do I mean by unnecessary code? Like, you're probably thinking, well, isn't everything in Kubernetes necessary? Why would they create a product with unnecessary code? But it happens all the time. And we also made a few enhancements. The code that we deemed unnecessary is code that is maybe not ready to use yet. So things like legacy and non-default features, things that are not turned on when you run Kubernetes by default, we went ahead and removed those. We removed alpha features. So those features are necessarily things that are not ready for prime time. So we said, all right, let's take those out. We removed in-tree cloud providers. So in the GitHub code base in tree, there is code for specific cloud providers. Now, some enterprises will use many cloud providers, and other enterprises are doing Kubernetes on-prem and they don't use cloud providers at all. And in the edge, you may not need cloud providers. So cloud providers have been removed. They can be installed using add-ons. And the same for in-tree storage drivers. So again, those have been removed. And then we removed the reliance on Docker. So you can use Docker, it's optional, but we're instead, as I mentioned before, we're using containerd. So overall, I believe we removed about 3 million lines of code. And that's done through patches, through code patches. So when new versions of Kubernetes come out, we can simply go through, review, run the patches, update. If an alpha feature became actual feature, then we'll need to patch it back in, things like that. But overall, I think it's about a 2-week process for us to patch a new version of Kubernetes. So we're not too far behind the upstream. So what did we add? So we simplified the installation. We added the ability to use SQLite 3 as the database for Kubernetes. K3s does all the TLS management for you. So this is one of the complexities of setting up a pure Kubernetes cluster. We also do something called automatic manifests. So automatic manifests and Helm chart management are where we will allow you to drop a file, so a YAML file, into a directory, and K3s will scan that directory and automatically pick it up and run it through the Kubernetes process. So Kubernetes will do its thing, but in the edge cases, this can be quite valuable because you might want to deploy something with preloaded containers and preloaded images or preloaded YAML descriptions of your application. And then we added the ability to do containerd out of the box, core DNS, flannel. One thing we don't mention here is that we're also using traffic as default ingress controller. And the part of the decision for using traffic had to do with the desire to release on ARM. So in order to release on ARM, the Nginx ingress controller is I think, dropping support for ARM, so we just went ahead and used traffic. So how does it work? If you've seen the Kubernetes diagrams, this looks very similar. So there's an API server, there's a scheduler, there's a control manager. This shouldn't look too different than Kubernetes master. And when we talk about Kubernetes masters, we're usually talking about the data plane and the control plane being put into a single place, to a single server, and we call those the master. And then we have the workers. And in this case, we're separating these out as server and agent. Now, the one thing that's a little bit unique here is this tunnel proxy in the middle. And that's a proxy between the server and the agent. The communication is always done from the agent and sets up that tunnel. And then there's actually quite a bit of communication between the server and the agent, but all the appropriate ports and connectivity is set up through that tunnel. So we're getting a secure tunnel for communication between these two. So what are some use cases for K3s? You probably came here today with your own use cases. We're seeing use cases obviously for edge computing. I would say a little bit less for embedded systems, although we are seeing for edge computing this sort of interest in a single device that has a Kubernetes cluster and can run containers. And the value there is that you now have this sort of deploy in a box, very simple, just turn it on type of system that's reliable and more robust. And you don't have to upgrade the firmware in order to upgrade the system. So it's not exactly an embedded system, but it's very similar to what embedded systems look like today. We're also seeing the K3s being used in IoT gateways. So all of the IoT devices are collecting data, managing data, computing data, and then they're going to send that data somewhere. And so they send it through a gateway. And so we're seeing K3s used on gateways, both as a processing unit, as a worker, as well as a way to send the data back up to a cloud. So rather than process the data on the cloud, pull it back down, you can actually process it locally, depending on the edge setup, and then push only what's necessary up to the cloud, or pull only what's necessary from the cloud. Another use case is CI environments, so continuous integration. And K3s is interesting for continuous integration because it allows you to very quickly stand up clusters and then tear them down. And we'll explore that a little bit with a tool called K3d today. Not exactly, I won't exactly show you CI, but I'll show you how developers can take advantage of some of the tooling that's out there. And just out of the box, K3s is very simple to install and stand up and run, and then tear it down. And so CI environments are a great use case for K3s. And then I talked a little bit already about the single app clusters and the similarity between what people do with embedded systems and the updates. So the single app clusters are being used in a variety of ways. We're seeing them in retail environments as well as warehousing and things like that. All right, so it's demo time. I'm gonna just move right on to installation and upgrade and show you how to install K3s and how to upgrade K3s. And we're gonna try and take little steps at first. We'll take baby steps, and then as we go through, I'll reuse some of the things that we do here to get a little more advanced and show you some more advanced things. So as I mentioned, K3s is available for x86 and ARM architectures. And it needs to be Linux on those architectures. Now it's possible, and again, later on I'll demo this, but it's possible to run K3s in a Docker container, in which case you're able to then run it on systems like the Mac OS. So this is Linux, x86, and Linux ARM for K3s right now. So here's what we're gonna do. I'm gonna install a version. I'm gonna install a version of K3s. I'm gonna install an older version. And we'll do this through the systemd script installation method. And then I'll do a systemd script upgrade. And I'm gonna upgrade to a release candidate. And then I'll do a script installation to the latest version. And the latest version is the latest release. So it's actually a lesser number than the release candidate. And then we can uninstall everything. All right, so let me bring up so here I just have a terminal window, and I'm going to log into. I have a bunch of AWS servers that I set up for this, and I've set up some scripts so that I basically pull down all the IDs of the AWS servers, and then I run this script. So here's what I'm running. SSH connect is a script I wrote, which looks at that list of IDs I have, and I'm getting ID number 2, which correlates to a specific server that I want to use, and I know which server that is, so I'm going to use that as my main server right now. And then I've got my key, and this just looks like a regular SSH command from here. And then I turned off strict node checking so that the first time I logged in, it won't give me an error saying that I, do I want to accept this unknown host? And so here I am, I'm in this server, and let's take a look at the architecture of the server. So you can see here that this is an x86 server. And what I'm going to do is I'm going to run this command I'm going to create a curl command. So this command says curl be silent and follow any links and pull down this k3s.io, get.k3s.io. That's a script. And that script, we're going to pipe it through SH, but we're going to give it an argument. We're going to give it the version argument. We're going to say install version 3 of K3s. So we'll run that now. And you can see that Kubernetes is now installed. And I've installed Kubernetes version 113. And I've got K3s version 0.3.0. And you can see when I ran the script, it actually told me which version I'm using as the release version. So that was a simple install. And now what I want to do is I want to upgrade. So I'm going to run this same script, the same command, but this time I'm going to run it to a release candidate. Now I'm going to run kubectl version again, and this is going to fail. It fails because there's a difference between the versions. So the version 3 it allowed me to use the kube config regardless of what user space and what user I'm logged in as. And the later version has a little more security, and so I get this error about actually that my kube config file is not accessible. So I could run the command with sudo, and then I would get some information, but I don't want to type sudo every time I do this. So I'm actually going to run this command. This is a similar command. It's the same curl command. Again, the same install version, but this time I'm going to add an exec install K3s exec argument, and it is this -- write kube config mode, which is exactly what it told me to do here, right? It said, please start the server with kube config mode to modify kube config permissions. And this is good if, again, for exactly this reason. So if I want to run kubectl without sudo as this user, I can change the mode of my global kube config. For security purposes, this is not good, right? So I'm doing something to get around the security of this. The other way to do this would be to grab this kube config file, bring it local, change it just for the local user, and not change the mode for all users. But for the purposes of this demo, this is how we're going to do it. And so you can see now I've got Kubernetes version 114. And my K3s version, again, mentioned up here. So let's do one more thing. Let's go ahead and this time, let's just install K3s latest. So I'm going to take the install version off this command. And you can see we're now using version 6.1, 0.6.1. And our Kubernetes version is still 114. All right, so that was install and upgrade. Pretty simple. It's definitely not Kubernetes the hard way. If you're familiar with that Git project, Kubernetes can be much more difficult to install, but we now have a cluster management, container orchestration, Kubernetes, that was installed with a single binary very quickly. That script, what that script did is it installed into to use systemd and to set that up where it's running as an init script, and I can start and stop using system control. So that was just a single node cluster. And if we take a look here, actually, you can see I have this one node, and that is the node that it's running on. But let's create a multi-node cluster. So what I'm going to do is I'm going to stand up K3s as server only on this same node. So I'm going to uninstall. I'll show you how to uninstall K3s. Then we'll install it as a server, but with no agent. So right now it has a server and agent on the same node, single node cluster. So we'll stand it up as a server, then we'll get the node token for the agents, and then we'll start up the agents. And we'll do the agents slightly differently. Instead of installing via the systemd script, we'll actually just install the binary. And I'm just doing this just to show you that it's possible to just pull down the binary. So depending on your use case, maybe you don't want the systemd script for various reasons. You can just install the binary, and then we'll connect the agents, and we'll take a look at some resource utilization and some other things as well. So let's go ahead and uninstall. Now, the uninstall script is mentioned right here during install. So now I'm gonna, now that I've uninstalled, I'm actually gonna install it one more time. You can see this curl SFL command again. This time I added to my K3s exec, I added the disable agent. And that's gonna install it so there's just the server. I've got my kube config mode to 644, and I'm actually setting it up. Remember I said it does TLS management for us. Well, I wanna make sure that my public IP address for this server is in this command. Is part of my certificate. So I add it to this command to make sure my certificate is capable of being recognized by the outside, that my cluster is capable of being recognized by the outside. Great, so. And here we'll see nothing. It doesn't even tell us that there's a server node right now. But we've got K3s started, but we can't run anything. We don't have any workers. So let's create some workers. So this top one is my server, and I'm going to add an agent on the bottom. Whoops. Again, using that scripted command, so I know which server I'm logging into. Let's take a look at what is this. Again, it's an x86 system. And this time what I'm going to do is I'm going to install K3s as a binary. curl-l follow links -o, write the file at the thing that's downloaded as K3s locally. So we're just going to pull that down. And I'm going to change the mode and move it into user local bin. And now I'm going to get the node token out of the server. So the server actually contains the token that allows me to connect. And I set up this echo command. This is actually giving me the export command that I'm going to use to create the node token on this agent. And so now we've got just a variable here, an environment variable that looks like that. And that's going to allow me to run this next command, which is going to run K3s in agent mode. So I have K3s here. And I'm now running in agent mode. And you can see I now have a node connected. So this server is now connected to that server. So we've got a small Kubernetes cluster. Let's do that again. This time, let's do it on an ARM server. You'll notice my my command is a little different. This time I'm pulling down K3s ARM64, but I'm still calling it K3s here. I changed the mode. And then again, I need this, this node token. This is like a pre-shared key. And now if we take a look here, we've got two nodes. Did I do uname-a on this? So this is a Arch64 ARM server. So now this cluster has one ARM server and one x86 server as its nodes. And of course, your containers would need to be able to be appropriately deployed to those nodes. So let's take a look at more about K3s on ARM. We did this. So K3s for the edge. ARM is one of the most common architectures for edge devices. And so I want to specifically just show you some things about ARM devices. I'm going to put K3s on a Raspberry Pi 3A Plus. So this is a very small device. It has 512 megabytes of RAM. And as I mentioned, K3s uses about 250 megabytes. Now, that's if we run it as the server and the agent together. If I just run it as the agent, it's going to be less than that even. But I'm going to run it all in one. This will be an all-in-one device, so a full Kubernetes cluster on a Raspberry Pi. This has a quad-core ARM v8 64-bit system on a chip. So it's a pretty small system. It's actually sitting here with me in my living room. And what I'm going to do is I'll use the install script on this Raspberry Pi device, and then we'll run the server. We'll take a look at some of the resource utilization. And actually, before I uninstall it, I'm going to go ahead and create some deployments and other things in that as well. So let's take a look at this. So just so you know, what did I just do? This is iTerm2, so I just logged into this one server in all three windows. So let's run htop in the upper window. Htop is more of a graphical top that comes on Debian and Ubuntu systems. This has Raspbian OS on it. And you can see I've got 4 cores, I've got a small amount of memory. The green bars in the memory, that's the used memory. And the yellow is cache. The blue, I don't recall what blue is. I'd have to go look that up. So we're not using very much memory right now, 54 of 432 megabytes. I've disabled the swap on these before, but with modern Kubernetes, doesn't matter. So now we have a very small device, and we're going to run K3s on this small device. So we'll do our curl command, and this should look familiar to you, right? It's the curl command with get k3s.io. We're going to use the kubeconfig mode 644. Actually, let's run a uname-a so you can see what's going on here. Look at that. It says ARM version 7, and I told you a moment ago that it's ARM 64. So Raspbian, for whatever reason, the current version of Raspbian reports this as an ARM v7 system, and so I have to run it as an ARM v7 system. So I actually run the ARMHF version of K3s on this, and of course the script detects it properly, and it works just right. But if I had a different OS on this machine, it could be ARM 64. Now this takes a little longer, and you'll see the CPU, those 4 cores are going to get jammed up as it starts pulling this down and trying to run it and load it, things like that. So while we're waiting for that to happen, let's talk a little bit about deployments. So we can, I have an Nginx YAML here. So this should look pretty familiar. It's just a Nginx deployment. Now, while the Nginx drops support for ARM, they do have some containers that work for ARM. So that's why I'm using this. It's really just a very, very simple, basic web server. And you can see it's going to go on container port 80. I'm not even going to set up a service to access it. I just want to demonstrate the deployments. So let's take a quick look. So deployments in K3s, you can do the standard Kubernetes approach, which is things like kubectl apply-f and then the file name. And I'll do that first. I'll show you how that works. It's just Kubernetes. But then, as I mentioned before, we also have the ability to use the manifest and to take that file, drop it in a location, and then let Kubernetes just do its thing. So it's K3s is gonna load that into Kubernetes for us. And if it changes or updates, Kubernetes will just pick it up and run with it. So we're still waiting for this to load. Let's quit here and just get ourselves ready. At this point, Matthew, do we have any outstanding questions that I can answer?
There are a couple. One of them is kind of a use case question for K3s. Another one is about K3OS. Do you want to take those now, or do you want to wait?
Let's talk about, yeah, let's see if I can answer the use case question. I will talk about K3OS a little bit later on. So maybe I will reserve that and see if I answer that question through the demo.
Okay, cool. All right, so here, this is from Kumar, who asks, he says, I'm interested in multi-master K3s. What are your thoughts on how to do this? Is it to use etcd, or do you envision anything else better going forward?
That's a great question. So we definitely are working on a multi-master K3s. So it's actually already in the works, and I'm not sure what version of K3s it's going to be delivered in, but that is part of what we're doing. So yes, you can use etcd. That is part of why we're looking at these other relational databases as well. Right now, the best thing, if you really want to do multi-master K3s, follow the project. We have a Slack group. We have a general channel for Slack with a K3s channel, and you can get into the conversation there. If you want to see how it's being implemented, and also if you want to contribute back to the implementation, as I mentioned, open source project. So that would be great. In addition, something that I've been working on, so we're running this Raspberry Pi device that we have in the background here, and I am working on some other demonstrations that involve turning an agent into a master. So one of the interesting things about edge devices is that they have different considerations for power outages. And so you have to look at your use case and consider, do I need multi-master, or do I need to pass the control over to another single master? So I'm working on a scenario and a demo of, if I pull the plug, I've got a battery backup for my small device. Once it kicks into the battery backup, it recognizes that the power's gone down. It'll use the battery power to ship the database over to one of the other nodes and tell the other node, hey, turn yourself into a master node and have everybody reconnect to you. So there are a couple of options there. One is for the multi-master and to follow the conversation in the K3s Slack and online at GitHub. And the other is to consider, the sort of migrating masters, which is just something I'm working on as well. All right, so it looks like we've got our K3s installed here. So let's take a look at what we've got. And I like to leave HTOP up because you can see when it's working really hard. There we are. We have a single node cluster. I'm going to go ahead and apply this, and we'll get Nginx deployed. And then over here, we'll do, let's see, let's watch. See what's running here. So you can see the Nginx container is not quite ready yet, still creating. While it's doing that, I'm going to prepare the next command here. So I'm going to delete this. Once it comes up, I'm just going to go ahead and delete it. And the reason, there it is. Okay, so now we have our Nginx deployment. And you can see the memory. We still have plenty of memory left we could run multiples. So I'm gonna delete that, and then we'll actually drop it in the manifest directory. Let's actually, I'm gonna get out of here. We'll open this up a little bit more. And oops. Okay. I'm going to go ahead and change this to 3 replicas. And then we'll go ahead and we'll copy that into the manifest directory. So I've copied it here to var lib rancher K3 server manifests. And K3s is actually going to pick that up. And you can see I've got three running now. So part of why was it taking so long, why was container creating, is I had to download it. It took a little bit of time, but it's already downloaded. So those three came up very quickly. And you see again, so I have three containers running. My memory is not terrible. My CPU, it comes and goes, right? But there's certainly enough if I needed to run some processes. So this is K3s running in a very small space, and I think it's kind of impressive. All right. So we did some deployments. Let's talk about K3D. I'm going to quit out of these. And actually go back to a single screen, clear it. So K3D is another project that was actually, it's also an open source, and the K3D project is something of a developer project for K3s. So, and I have installed K3D through Brew. I'm using a Mac. Let's see, what is it? Brew info K3D. Okay, so it's already installed, and it is it gives us the ability to run K3s in Docker. So we can create clusters very quickly. A single node, the default is just K3D create, and boom, I've got a cluster. Multi-node with a name, K3D create -- name, give it a name. How many workers do I want? So K3D is really, really cool when it comes to like local development in Kubernetes. So let's run those commands. So first of all, let's look at K3D help. So there's a bunch of commands: start and stop clusters, list the clusters. Right now you can see that I have no clusters running. And if I do K3D create, and then we list, you can see I have a cluster running, and it gave it the name K3s default. It also tells me if I use this kubeconfig command, I can get my kubeconfig from K3D itself. So I'm actually going to copy that. We'll paste it here, and then we'll do kubectl get node. And it created a 3-node cluster for me by default. Actually, no, that looks like that is a different cluster. Let's do the export on kubeconfig. I think because of the way I wrote that command, that's not the right kubeconfig. There we go. So we've got a single node kubectl, a single node Kubernetes cluster. Let's do it again, but this time let's create one with multi-nodes. So we're going to do a K3D create. We'll give it a name, and we'll give it some workers. And then we'll do a K3D list again. Could create container K3D cluster 01 server. Because I have that single node cluster. Let's do K3D for this, I'd rather get up the multi-node cluster, delete. So I need to add other arguments in order to use a different bind point for this next cluster. So I'm just going to delete all. And then we'll run this command to get a multi-node cluster up and running again. So I've got a server and 3 workers in this cluster. So that's K3D. It's using K3s under the hood to create these clusters, and it's pretty powerful and pretty simple. And obviously, you can see it installed really fast. I'm just on a standard network to get this thing set up. Okay, so let's talk about K3OS. So K3OS is the K3s container operating system. So it's an operating system that has containerd as its initial process. So as PID1. Why have a container operating system? So the value of container operating system is that, and specifically K3OS, is that it allows you to run on multiple architectures. So you can run K3OS in multiple architectures, like the same as what you can run K3s on. It's considered more secure because it really only runs the minimum required services. So fewer services means a smaller attack surface, and generally it's considered a more secure. The smaller your attack surface, the more secure it's considered. It doesn't require a package manager, so I don't need apt or yum to deploy applications. Of course, I'm going to be using Kubernetes to install applications, and all my applications run. So there are actually 2 container daemons. So there's the process, the system container, in this case, containerd. So, and then there's the user containerd. And so you run your apps in the user containerd in containers. And the interesting thing about K3OS is that it models infrastructure as code. And so it makes it really easy to kind of do everything you want to do with installing Kubernetes clusters through version control systems with configuration management. And I'll show you, I'll demo doing it with Vagrant and VirtualBox on my local machine. There are a lot of ways that you can do K3OS installation. I'm really only going to do one of them, but I'll just go through the list. You can also get this list. So K3D, K3s, K3D, K3OS, these are all open source projects, and they're all under github.com/rancher, and I'll give you the list of them a little bit later on. So the first installation method is the interactive method. So you mount the ISO and then run osconfig, and it'll walk you through installation of K3OS. We're going to do a semi-interactive one. When I do it with Packer, I'll do it with Packer, Vagrant, and VirtualBox. And with Packer, we'll actually run the script that we would have run osconfig. There's an automated method, and that's with kernel command line parameters. There's a bootstrap method where you can use the install.sh script, which you can find on GitHub, and install to a block device. You could remaster an ISO with the grub make rescue utility. You can do something that's called a takeover install. And so this one's a little bit crazy, and I actually have a little I haven't done it yet, so I have a little trouble wrapping my head around it. But basically, um, you can basically take over the existing Linux OS. You know, this is actually not that unusual if you think about it, right? If you swap out some of the kernel information, then you have something else underneath when you restart. And so that's what this install sh with dash dash, that's supposed to be a double dash, but PowerPoint likes to make it into a single long dash, take over. And then you add some arguments. So you'll add your command arguments similar to what you would do on the automated command line parameters and take over the OS. And then specifically for ARM, you can do this ARM overlay where you use an archive of root fs and you extract it out, and then you use the config.yaml. So these are all similar methods. They all have some way to add parameterization to it, but there's sort of multiple different ways to do the installation. So let's jump into that. I hope you can see this. Let's see if I can get the, yeah. Hopefully that's a little better. So here I am in Visual Studio Code, and I've just got this directory. I've got some, basically, the only thing we really care about is that I've got this vagrant file, and I've got an configuration file. So this configuration file is what I'm going to use for Packer, and I'll run Packer against this config file, which says I'm going to make a VirtualBox ISO, and I'm going to run this boot command, which is going to use that. It's going to use that os config command right here, and then I have some just some more parameters that get entered as it goes through, and we'll get a Packer configuration set up here. So we're going to do very simple Packer build vagrant.json. And hopefully you can see that black on black. Basically, VirtualBox pops up a window. So this is, that's K3OS. It's the ISO. If I was to just run the ISO and then shut it down, obviously it's not installed anywhere. So we're trying to do the installation. It looks like it failed. I'm not sure what failed here, which means SSH isn't going to come available. Well, what kind of demo would this be if I didn't have some sort of bump in the road? I suspect I did not delete an old Packer box. So basically this is K3OS. It would have run some commands with the OS config, and it would have created this Packer machine. And then Vagrant would, and then, sorry, power off the machine. And then I would have a machine that VirtualBox could use. Because I am prepared for some of these scenarios, I have made a copy of the last time I did this in my boxes directory. So I'll just move that out. We'll move on to the next bit, which is that we're going to do a vagrant up, and I'll show you the vagrant file. So the vagrant file is very, very simple. It just takes that box that was created by Packer. So it took the configured Rancher OS box, and it's going to run it in Vagrant and run it in VirtualBox, but I'm using Vagrant to make that happen. So it's booting the box and it's going to log in. and with any luck, we haven't quite figured out I haven't figured out what guest operating system to use. I'm using, if you're familiar with how Vagrant works, if you specify a guest operating system, then Vagrant will do its best to make that guest OS work with VirtualBox. The problem is this is a container operating system, and I don't think Vagrant is quite ready for that. But now we can do a Vagrant SSH, and it'll SSH into my machine. And we have a single node K3 OS instance running. With 0.5.0. So I've showed you multiple ways to create clusters with K3s, but now I have this like plethora. I've got all these clusters, and so the next logical question is fleet management. How do I manage all these clusters? And we're seeing, especially with K3s and Kubernetes on the edge, we're seeing use cases where we're talking hundreds of clusters, sometimes thousands of clusters. So if you think about the use case for edge devices running Kubernetes in a warehouse, and then you think of the number of warehouses. I mean, so hundreds of devices in a single warehouse, multiple warehouses. It's exponential, huge amounts of clusters. How do I manage them all? One of the ways to do that is with Rancher. We are also talking about sort of a more edge-focused, about building a more edge-focused fleet management. But right now, the Rancher Labs tool, Rancher, again, open source product, is what we can use. And basically, the Rancher management server runs on Kubernetes. We have another open source product called RKE, which is a distribution of Kubernetes. It's the Rancher Kubernetes engine. And that's a full-blown Kubernetes distribution, again, upstream Kubernetes. So Rancher, the Rancher management server, we wanted to build an application that could manage other Kubernetes clusters. And so if you were building an application, and you wanted to be robust and highly available and scalable, what would you build it on? You'd probably build it on Kubernetes too. So we built it so that it runs in Kubernetes. It's using Kubernetes resources and custom resource definitions to run an application, which is called Rancher Management Server. That then can manage these clusters, whether they're edge clusters, gateway clusters, cloud. A cluster is a cluster is a cluster. If these are upstream Kubernetes clusters, they don't even have to be created by Rancher. These could be kubeadm, kubespray, custom clusters. Doesn't matter, as long as it's an upstream Kubernetes cluster and we can run a node agent and a cluster agent, we can connect it to Rancher. So let me also show you that. Let's go here. Actually, let's take a look at the, let's see if I can get into, I had a problem earlier. I was actually not able to get into the site. Yeah, I'm not gonna be able to demo this part of it. So right now, I do not have a demo environment that I can run Rancher Management Server in. And so I'm going to end the demo here and see what other questions we might have.
All right, cool. Thanks, Mark. Awesome stuff. There are a lot of questions, unsurprisingly. So let's get going on these. So this is from Kevin, who asks, K3s, awesome product. Thank you so much. What criteria will determine when K3s goes GA, and when do you see that happening?
Kevin, that's a great question. We really want K3s to be secure, and I believe that HA an HA master is part of having it go GA. And the expected timeline is this year. I don't know if that's Q3 or Q4, but we definitely want to have it generally available this year. So I hope that answers your question.
Okay, cool. Thank you. This next one is from Andreas, asked near the beginning of the demos, and I think this is a question, not a request, but here it goes. It says, can you configure the Raspberry Pi device as K3s agent for the x86 server in a multi-architecture scenario?
I'm sorry, can you ask that question again?
Sure, yeah, and if you, it might be easier, it's kind of long, and if you need to look at it, it is one of the top questions in the list, but it's from Andreas, who asks, could you configure the Raspberry Pi device as a K3s agent for your x86 server for a multi-architecture scenario?
Absolutely, yes. So I think what you're asking is, could I have my agents or an agent be composed of Raspberry Pis? And yes, I've done it. It's actually the exact same procedure I showed you for connecting those other ARM servers. And so you can have your master or your server be an x86 architecture, and then have your agent be an ARM architecture, and that's just fine. And in fact, not only that, you could drop that Nginx YAML into the manifest directory like we did, but you'd be doing it on the server. You'd do it on the x86 box. Kubernetes, when it goes to create those containers and those pods based on that definition, when it goes to create the deployments, it's when it deploys to your Raspberry Pi, it will deploy the correct architecture, and when it deploys to your ARM, your x86s, it will deploy correctly to that architecture. Now, the caveat there is that Nginx currently has containers for both of those architectures. So it is able to download the correct image for the architecture. If you try to do that without taints and tolerations or some sort of node affinity, and you had containers that wouldn't run, that weren't prepared for Raspberry Pi architecture, for that ARM architecture, then you would get some crash, some back off crash loops when you tried to install that thing. So if you want to try that, it actually works with Nginx, and it is actually something that I've done before. So it works nicely. Thanks for the question.
Okay. Awesome. Okay, here's the next one. I'm sure I'm going to butcher this person's name. Remigius. I hope I haven't just obliterated your name, but he asks, is it possible to run K3OS on A1 ARM instances in AWS? Mark, are you still there? I think we might have lost your audio. I cannot hear you.
Sorry, I had gone on mute. So
Okay.
the answer is yes. It's possible to run K3OS on AWS on the A1 instances. If we go back here, so you would, I would recommend trying the takeover method. The challenge, of course, you're going to have is what currently, what does the how does AWS do it? I have not done this. Theoretically, it should be possible. You would use your cloud config. So the cloud providers have this concept of cloud init, you would need to use some of those parameters to be able to do this type of thing.
Okay, cool. Thank you. Actually, keeping on this slide, the next question is from Vishal, who asks, could you explain a little bit more about the overlay installation method? What does it do exactly?
Sure. So the overlay installation, you actually are going to overlay the root file system. So you're going to take, and this might be, we might just want to go to the web page. Let's see. You're gonna download a root fs tar file. You're going to extract that and install that into the file system, into the existing operating system location. So let's go to, let me pull this up here. Let's see. All right, so you should be able to see my browser, and we'll go to github.com, Rancher, K3OS. Go to the installation section. These are all outlined, all the types are here. Here's the ARM overlay installation. So you're gonna download this K3OS rootfs file. There's instruction right here. Note the you're stripping the components, you're stripping the path. You're gonna set up your YAML configuration, and then you're gonna run a sync. And this is just specific to ARM. So my suggestion is come on over to the GitHub page, check out this ARM overlay installation, and run these commands.
Okay, awesome. Thank you. Here is the next one. Can K3s use different networking outside of Flannel, Calico, Cilium, etc.?
Absolutely. You can disable the networking. There's a flag, so there's actually quite a number of flags you can run. So let's see, where are we? We're here. Let's log back into one of these servers. Actually, what do we have running in K3D? No, let's log into one of these servers where we have K3s running. Okay. I think I'm on the server node. Yeah, okay. So if we run server help, you'll notice that you have the ability to disable flannel, -- no flannel. And then you can set up your own CNI.
Awesome. Okay, terrific. Here's the next one. This is from Daryl, who asks, how does K3s or K3OS work in an environment without internet access?
You can install any of these in an environment without internet access. K3s is designed, and there's actually content on the website. You can pull down the binary pieces that you need for K3s installation. So let's go to the K3s site here. And what we search for is air gap. So for K3s, you're going to run air gap in this way. Um, for K3OS, you will need to download the ISO and mount the ISO into a machine, and then do an OS config, or depending on where your servers are and what methodology. They're all very similar. So basically, as long as you can get access to that ISO for K3 OS, you're able to basically put in an air gap scenario.
Cool. Okay, thank you. Awesome. Let's see. Okay, these next set of questions are from Victor, and I think they all refer to K3s. He
Okay.
says, any plans of releasing a version for Kubernetes 1.15?
Yes, actually, that'll be soon. So 115 was released 2 or 3 weeks ago, and we're working on the patches to release 115. What I'm not sure of. So if you go to the release list on the K3s site, um, you can see that we have a release candidates coming out here. And I just don't know whether this is going to be 115 yet or not. 114, that's version 6. It may be that the actual version 7, 0.7.0, minor release 7, is going to be with 115. I'm not really sure. You could check on the Slack group, on the public Slack group for K3s. I would search for that question, and if you don't see it, just ask.
Cool. Okay. And so this is the next one from Victor. Is it possible to change the default node port range? Default is 30,000 and above, it appears.
Yep, yep. So you can change your node ports, and let's see. I'm not sure what the command is, but there should be a command within the K3s server. So if you do K3s server -- help, we should be able to change our node ports. But I don't know the exact value, the exact argument to do so.
Okay, cool, no problem. Here's the next one, also from Victor. He says, if Docker is not installed, what do you use to manage the images?
Sure, that's a great question, Victor. I think I should probably add that to the demo in the future. So basically, we're on this server, and K3s is installed, right? And we're using containerd, and part of the K3s installation is crack control. And crack control operates just like Docker. So you can run the same commands through crack control. I'm going to need to sudo, whoops. And this will get me a list of the running processes. It should. Why is crack control not working? So you'll notice that it has all the same commands. So you've got ps, exec, create. So this is all the container management. Actually, Docker uses this under the hood as well. I am not sure why crack control is not working for me. Guessing it's something to do with my user space. Context deadline exceeded, failed to connect. So that's the answer. Crack control is the answer.
Awesome, thank you. Here's the next one from Rodrigo. Which OS version it was used on the Raspberry Pi in your demo, and what do you recommend is the best choice?
So I was using Raspbian on the Raspberry Pi, and I was using the latest version of Raspbian um, because this is a Raspberry Pi 3. So it's the 3A plus, and there are other operating systems. You can install K3OS as well. Um, I prefer Raspbian right now. For the types of things I'm doing, I prefer Raspbian because there's a lot of documentation around GPIO access, and for me, that's the value of edge devices. And these Raspberry Pis is the general purpose I/O. So if I want to attach some input or output device like a speaker um, or a buzzer or some sort of a touch input sensor or any input sensor, I can do that. And there's documentation for how to containerize those and get access to the GPIO through containers. So that's why I use Raspbian. And that's just my preference. There's obviously other options, and I will be working on using K3OS in the future as well. K3OS does allow you to connect devices, but it's you know a little bit more configuration because Raspberry Pi has such a big community right now.
Right.
Thanks.
Awesome. Okay. We're coming to the last few questions here. This one, and thanks everybody for your patience. I know some of these were asked a while ago. So this is from Jack, who asks, is K3D, or can you run K3D on Raspberry Pi 4?
Can you run K3D on Raspberry Pi 4? I see no reason why you wouldn't be able to. I have not tried it. I have yet to get my hands on a Raspberry Pi 4, but it fits all the general requirements. So it's a Linux operating system. It's ARM based. So there, in theory, yes, you could run K3D. If you look at that's the one site we didn't pull up yet. If we look at the K3D site, oops. Um, Basically, there are instructions here for installing K3D, not through Brew. So I did it on a Mac OS, but you can install it just on a standard Linux system as well. So the answer is yes.
Cool. Okay, great. This next one, thank you. The next one is from Andreas, who asks, does the Rancher web UI handle K3D? And if not, are there plans for it too?
So I'm not exactly sure what that question is asking. So the Rancher, so the Rancher management server does not deploy. Right now, we don't have any utility within Rancher management server to deploy K3s clusters or K3D based clusters. However, all of those cluster types, once you have the cluster, and that was the part of the demo I wasn't able to set up, having to do with the certificates on the site that I usually demo with. Seems like Let's Encrypt didn't update them. But anyways, I can import any of these clusters because they're all upstream clusters. We can go ahead and we can actually import these clusters into Rancher. So regardless of how they're built, because they're all upstream Kubernetes, and they can all take these container agents and cluster agents and node agents, which are really just deployments that run in your cluster.
Great. Makes sense. Thank you. Okay, here's the next one. It's from Victor, who asks, does K3s support network policies?
The answer is if you change your CNI, then you can use something like Calico or Canal, which is Calico and Flannel, and then you have network policy.
Yeah, cool. Okay, here's the last question, Mark. This is kind of a request, actually. If you put together the alternative to multi-master setup that you mentioned earlier, would you post about it somewhere?
Absolutely. So um, I've actually committed to doing a demo of it at the ARM Tech Conference, which will be in San Jose later this year. Um, and I will most definitely be posting about it. Right now, I think most of my posts are on Medium, but I will, post in the standard K3s channels to let people know when it's available.
So good. Okay, well we've got the commitment here. That was the last question. Anything else you want to show us or leave us with?
So I have one more slide, and it's just the content that we went through today. So we actually I did pull up the K3s, K3OS, and K3D sites. You can get the script from get.k3s.io. That's the script I was running to install. And if you're interested in the commands, the specific commands that I ran, you can go to my gist. I posted them on a gist on GitHub, and I just shortened the URL because it was a really long string. So those are all available if people want to see it as well.
Super cool. Thank you. I'm sure that's going to be really helpful to a lot of people. Well, great. I'm going to take back the presentation just to show a last couple slides
Sure.
for people who might have missed this earlier. Sure. You can see my screen.
Yep.
Okay, great. So just as a reiteration, this really great next step is to join the Rancher Slack, slack.rancher.io, and the pound K3s channel, or just general channel. There's many other channels on K3D, I'm sure, or K3OS that might not be listed here, but just search for them. We'd be surprised if we didn't have a channel on them. And otherwise, that is everything that we wanted to show you all. Thank you so much for attending. There is a survey at the end. If you're able to stay just a couple minutes, it'll pop up as soon as you leave, and you can fill that out. Let us know what worked, what didn't, any topics that you wanted to see covered that weren't. It'll help us craft the next session on K3s and these other projects. And if you like the session, give us a little shout out on Twitter. You can mention us at rancher_labs. We'll look forward to keeping the conversation going from there. And Mark, thank you so much. Thank you so much for all the prep work you did. A fantastic job.
Thank you.
All right, everybody, have a good one.